Hello everyone, my name is Devas Misra, and discovering logistic regression is the next step in my machine learning. As I continue exploring machine learning, today's topic is logistic regression, a technique that helps us to make decision, not prediction. It's simple and powerful. What is logistic regression? Unlike linear regression, which predicts continuous value, logistic regression is used for classification. It's answer a different kind of questions. Equation of logistic regression. 1 upon 1 plus e to the power minus b naught plus b1 x1, where the expression b naught plus b1 x1 is the linear combination of the input feature and their corresponding coefficients, which is then passed through the logistic function to produce the probability. This is the graph of the logistic regression. To implement logistic regression, I import some of the library files here. First library file is NumPy, which is the calculator. It helps with array and numerical operation. Second, Matplotlib is the artist. It lets us visualize data and decision boundaries. Scikit-Learn is the predictor. It provides the logistic regression model to classify data. I start by importing the dataset using load breast cancer function from sklearn.datasets and print to see the dataset. Once I had the dataset ready, I want to see if I could build a simple model to predict where it is beginnings. To do that, I used a popular algorithm called logistic regression. It's a great for binary classification problem like this. First, I split the data into two parts. Training set, which is 80% to teach the model, and test set, which is 20% to check how well it learned. Then I create the model using logistic regression from sklearn. I set a high max ITR value to make sure the model had enough time to learn properly. After training it with the data, I tested it on the unseen test and calculate the accuracy. This is the code, and we can see that the result is 95% accuracy. This step felt like magic. Turning a raw numbers into a working prediction engine, it's great reminder of how powerful even simple model can be when paired with clean data. Thank you.